Lovely introduction, and it's always a pleasure to work with you in any capacity. And I know you've heard me say this before, but the year that you kindly invited me to present at CI Live was one of my all-time favorite events. So I have that connection with you and Iowa, and I should also let you all know that we filmed a season 3 episode of Meteorite Men in Iowa. It was called Homestead, and we were investigating the enormous 19th century fall in rural Iowa near Amarna, if I'm pronouncing that, Amana, if I'm pronouncing that correctly. And we got to travel up and down the Iowa River in our amphibious vehicle looking for meteorites, which was definitely an amusing highlight of my career. So my interest in meteorites goes back to childhood. My father was an amateur astronomer. I've been a spaceflight nut, a science nut my whole life, and for me, my multiple interests really came together in one place when my late and much missed and long suffering mother took me to the Geological Museum in London, where I witnessed meteorites in real life for the first time, and I was astounded that so many examples had been found in large part by accident at that time. This is the 1960s when I was a little boy. And of course, the number of meteorites that we have today is vast in comparison. I haven't checked the database recently, but I think we're around 70,000 known meteorites in all of science. And in some instances, that's just one piece that fell. And in other instances, like Sukhotolin in Russia, thousands of pieces fell on the same day in 1947. So I'm going to start with a little bit of a show and tell, and then we're going to look at a few slides of my adventures around the world. And Calvin and Dan, your members, very kindly brought in Dan's meteorite collection. So we will try and have a look at that if we have time, if the camera cooperates. And we'd love to leave a bit of time for Q&A at the end. So save up your space rock questions. And I'm going to try and give you a mix of some of the scientific background information, what we know about meteorites and what they can teach us, and then also some anecdotes and tips and tricks about how we go out in the wilds and find them. So I'm going to start with this. Dan, I wonder if you recognize this meteorite type as a fellow enthusiast. I'll put it up a little bit closer to
looks
the
like
camera.
an iron to me.
It certainly is. And we describe this as a shrapnel piece. This is a piece of the Sukhotolin meteorite that fell in eastern Siberia in February of 1947. And it was the largest meteorite fall in recorded history. There have been larger falls in the prehistoric period, but in terms of an event that was actually witnessed and recorded by humans, this is the winner. Thousands of pieces fell at the same time and formed about 101 craters in a very heavily forested area. And this twisted shard-like aspect is why this is called shrapnel. This very angular look is a result of the force with which the initial masses crashed into the earth. So when you find an iron meteorite, they typically stand out and are easier to recognize than other types, but they're also rarer in number. So that's what we meteorite hunters are always dreaming of secretly, is finding an iron with a fantastic shape. Now, much more abundant than the iron meteorites is this odd thing that really looks more like a charcoal briquette than something that's traveled halfway across the solar system. This is described as a witnessed fall, much like Sukhotolin. This was seen to fall much more recently in Mali in Africa in 2007. So this piece was picked up right after it fell. And look at that matte black surface. That is the hallmark of a freshly fallen meteorite. And that black exterior is called fusion crust. And that forms when the incoming mass is superheated in the atmosphere, mostly as a result of air being compressed ahead of it, and also to a lesser degree by friction. And the exterior is toasted. So when there's a big fireball, like there have been several recently, there seem to be a lot more meteorites falling to Earth than there were when I first started out. But my co-host from Meteorite Men Steve Arnold is out on a hunt in the Midwest, and he was in Texas a couple of weeks ago. So meteorites are falling all the time. And if you're out searching for a freshly fallen meteorite, this is what you're looking for. Just think in the back of your mind, charcoal briquette. I'm looking for a charcoal briquette, but don't try throwing it in your hibachi. You'd really be missing out. But the most frequent find looks something like this. This is also a stone meteorite, so very similar in composition to the freshly fallen piece that I showed you. But this piece has been on the Earth for hundreds or probably thousands of years. And note that reddish bronze color on the exterior. That is because most meteorites are very rich in iron. This has been weathering out in the desert. This was found in Northwest Africa. And the iron content has oxidized, giving it that beautiful reddish bronze patina. And that is really that's what we're looking for most frequently when we're out in the world searching for meteorites. Irons are quite rare. Witnessed falls only happen a few times a year. Material is seen to fall to Earth and recovered. So most meteorite finds that are made, we might describe them as a cold find. Somebody is out walking the dog or treasure hunting or prospecting, whatever it might be, and sees this strange, very dark rock, often a smooth ablated surface like that. And so that this type of rock is what has led to the majority of new meteorite finds in history. All right, so I'm going to share with you a few photographs from my adventures around the world and a little additional information about meteorites, where they come from, what they look like. So as Tony mentioned so kindly in his introduction, I've done a lot of television in my professional life, mostly science-based, and notably Meteorite Men, which aired for 3 seasons on, we originally made the show for Science Channel, and it aired on Discovery networks all over the world. And we had some fairly prestigious guest stars, including this character that you might recognize from American Chopper. And one of the more amusing ideas during the Meteorite Men years was that we would do a pair of episodes with the American Chopper guys on TLC, which delighted me because I was a biker in my teens, and we had an actual 900-pound custom motorcycle built for us and delivered to us. And I always call that the Marvel team up episode for you comic book fans. So we got to go to American Chopper headquarters and confer with them on the design of the motorcycle and do an episode with them. And they came out to Kansas and met us in the field and delivered the motorcycle. It was quite a memorable experience. And the American Chopper guys were really extra enthused by this project because a lot of people who order their motorcycles, those motorcycles are very expensive, they're custom built. The majority of people who order one of those motorcycles, they do it for a prestige thing and they put it in their corporate headquarters or in their motorcycle collection. But we actually used this out in the field all over the States. We had it air freighted to Australia for 2 episodes. So the American Chopper guys were psyched that they were building a motorcycle that would actually be used searching for space rocks. And there is a column with a little dish on the top, and that was our very sophisticated GPS system that we used for mapping areas that we had hunted so we could cover maximum distance. As I mentioned at the beginning, I fell in love with meteorites at a very early age, and I've always particularly been fascinated by meteorite craters, by the point of impact where large space rocks have hit the Earth and excavated, in some cases, spectacular features. This is the erroneously named Meteor Crater in Arizona, and we'll get onto this in a minute. But when a crater is formed, it is formed by a meteorite, not a meteor. And I absolutely love Meteor Crater and have filmed there many times, and I'm a great fan of their work, but we're always quietly amused that it was accidentally named incorrectly. So what's the difference? Asteroid, meteoroid, meteor, meteorites. It's very complicated until it's explained to you, and hopefully this will resonate and make sense. One of the things that amuses me the most in my work is we frequently get calls at Aerolite Meteorites, my meteorite company, by someone who says, well, I was out walking the dog last night and the sky lit up and I saw things falling, and in the morning I went out to my driveway and I found a meteor on my driveway. Well, you couldn't do that. A meteor is not a tangible object. The word meteor refers to the atmospheric phenomenon that we see in the sky. In other words, a shooting star. Most meteorites that we have on Earth, the vast majority, originated on asteroids. And so the asteroid from which a meteorite came is called its parent body. Imagine out there in the jumble of the asteroid belt between Mars and Jupiter, you've got these giant building-sized rocks traveling around, and every now and then two of them will crash into each other and pieces will get flung out into space. Every now and then, one of those pieces crosses paths with our dear little Earth, hits the atmosphere, and as it's traveling through the atmosphere and becomes superheated, it forms a meteor. That's the shooting star. So if a meteor is an intangible object, what do you call the rock that's no longer an asteroid and hasn't hit the Earth yet? Well, that's a meteoroid. It's a potential meteorite. So the body, the rock, traveling through the atmosphere, forming that atmospheric phenomenon is the meteoroid. And when it finally lands on Earth, like this piece, it becomes a meteorite. So you are now all experts. Asteroid, meteoroid, meteor, meteorite, in case you get tested on it later. And here are studio photographs of the three main types. I showed you an iron meteorite, two different types of stones. So on the left, this is actually another example of the Sacodaline iron that I held up at the beginning of the talk. Fell in 1947. That is almost entirely iron. That's about a 93% iron mass with the balance made up of nickel and some trace elements. In the middle, the beautiful stained glass-like piece is a stony iron, the rarest of the meteorite types, a mixture of silicates and iron. In this case, the silicates are olivine, which is the gemstone peridot, and on the far right, a large stone meteorite, again showing that black fusion crust, which is caused by it becoming superheated in the atmosphere. Here's a close-up of a large iron. This was found in West Africa, in Namibia, and those indentations that we see quite frequently in whole masses of irons. I'll just back up because you can see the features very well on that iron on the left of the photograph are called regmaglypts, or unofficially thumbprints. And those are little indentations that are formed during a meteorite's flight through the atmosphere. And it's a feature that's unique to meteorites. Sometimes weathering on Earth, this is a very old meteorite. This was lay on the surface of the Earth for thousands of years. Sometimes exposure to the elements of Earth can cause those regmaglypts to shallow out and become larger, or even to be entirely new features that are formed by weathering. But that's one of the things we look for. That's one of the identification features of meteorites, are those little circular or oval indentations. Here is a large slice of the Brenham palisite from Kansas, and this really shows that mixture. Stony irons are about half and half nickel iron and half silicate material, in this case olivine. And then we have stone meteorites, the largest, the most abundant group. And these little colorful grains, these orange spheres that you're seeing, are called chondrules, and they date from the very beginning of the solar system. These were the building blocks of the rocky planets and asteroids. And these tiny little glassy spheres are believed to have formed during quite a short period of time at super high temperature at the very beginning of the solar system, in the solar disk, before the planets and moons accreted. So when we find meteorites like this is a carbonaceous chondrite, a very rare type. When we find meteorites that have these pristine, unchanged chondrules, we're really looking back billions of years to the formation of our solar system. And this is one of the ways in which the study of meteorites helps us understand our place on Earth and our planet's place in the solar system, in the galaxy, in the universe. It helps us to see the building blocks that formed our solar system. And we assume and expect that the processes were very similar, if not identical, in other solar systems and throughout the galaxy. And I can't talk to you about meteorites without mentioning moon rocks. And no, this is not a sample that was brought back from one of the Apollo missions. Those are curated by the federal government, and it is illegal for citizens to own lunar return samples, but you can own a piece of the moon that arrived here under its own power. And if you imagine in your mind's eye, it's a very nice, dark, clear night, and you're looking up at the moon, maybe through some binoculars, or maybe you have a telescope. And I don't have to remind you that the surface of the moon is covered with craters. And most of those craters were formed by meteorite impacts. Now, bear in mind, the moon has no atmosphere and significantly less gravitational pull than Earth. So when an asteroid fragment slams into the surface of the moon, it's relatively easy for pieces to be blasted off, and some of those pieces find their way here to Earth. And it was because of the Apollo missions, and thanks to the work of the Apollo astronauts and the moon rock collectors, that we know those are lunar meteorites, because they are, in most cases, a very close geologic match to lunar return samples. And I always find that one of the most fascinating places in which meteorite science and the space program overlap. Without the sample return missions, we wouldn't really know for sure what those meteorites were. And if that's not proof positive that we really went to the moon, I don't know what is. Speaking of, there is another very interesting crossover between meteorite science and space flight. Early spacecraft designers studied oriented meteorites to get a better understanding of how heat shields on capsules might work. Now, oriented meteorites have a very familiar shape to you spaceflight enthusiasts. This is a button-like iron meteorite, and its surface has ablated as it traveled through the atmosphere to form that dome shape. Here's another example. If you look along the top half of this meteorite from left to right, you'll see there's a sort of a rim there. There's quite a clear pair of horizontal lines. That's called a rollover lip, and that's where molten material actually rolled back to the trailing edge of this meteorite as it was hurtling through the atmosphere. So spacecraft designers wanted to understand how best to ablate heat off the heat shield of a returning spaceflight capsule. It's traveling very fast, in many cases carrying valuable humans aboard. This is one of the largest oriented meteorites ever found. This was found by my co-host Steve Arnold from Meteorite Men in Kansas. And doesn't that look kind of familiar if you were to just rotate that image? So the ablated shapes in meteorites were a boon to spacecraft designers. And once when I was filming an episode at NASA Dryden, which many of you will be very familiar with, we went up there to do an episode about SOFIA, the 747 stratospheric observatory, and we did a wonderful interview with a NASA spacecraft designer. He was absolutely fascinated by oriented meteorites, and he said, anytime you find any really wacky oriented meteorites, you let me know. We'd love to borrow them because they can still have influence on the design of spacecraft. I always just find that marvelous. So how do we find meteorites, and what happens to them when they land on Earth? Well, despite what you might have seen in Armageddon or Deep Impact or some of these other wacky films, meteorites are not burning hot when they hit the Earth in most cases. In fact, the vast majority of meteorites fall to the Earth and land at just a few hundred miles per hour, maybe roughly the speed of a golf ball. And that's because as they get closer and closer to the Earth, the increasing density of atmosphere slows them down, and they end up falling at a fairly modest terminal velocity, say 200 to 300 miles an hour would be average impact speed, which is still significant if it's a large iron. If it was a bowling ball iron, it's probably still going to go right through your car. But most meteorites land on the surface like this. This is a piece that I found in West Texas just a few days after a spectacular fireball was seen over Waco. And note the little indentation that it made in the ground. That's what will happen when a not particularly dense rock weighing maybe 20 or 30 grams hits the ground at 200 or 300 miles an hour. It's called an impact pit, a small indentation. Now, a larger meteorite will make a larger impact pit. And there I am in the Atacama Desert in Chile, wishing that someone hadn't removed that meteorite back in the 1800s. It now lives at the Natural History Museum in London. And in fact, was one of the things that really inspired me to become a meteorite specialist and a meteorite hunter. This beautiful giant Immolac palisite in the Natural History, then the Geological Museum at the time in London. And I was thrilled to locate the impact pit that it made when it fell to Earth thousands of years ago. And it was discovered in the 1800s by a gentleman adventurer who somehow managed to get it onto the back of a camel or a couple of camels and get it out of the Atacama Desert and back to London, where it now resides in the Natural History Museum. Well, here's a slightly bigger one. This is Henbury Craters in Australia. This is the smallest true crater that I visited. And by true crater, I mean it was formed by the explosive impact of a meteorite. And we know that because we found small fragments around the rim. And that is believed to have been formed about between 4,000 and 5,000 years ago. This is the Whitecourt crater in Canada. This is a very recent discovery. This was actually first identified while we were filming Meteorite Men, and we were some of the very first people to be allowed to go to the crater. It was definitely one of the highlights of my career. And we went several times at the request of our colleagues in academia in Canada to help them recover as many meteorite fragments as possible. And thousands of fragments were found, and a very detailed three-dimensional map was made. Not only were we given access to this restricted area where, as you might be able to read on the sign, it says, no disturbance or collecting allowed. Violation is punishable by a fine of up to $50,000 and 1 year imprisonment. And despite that, people were sneaking in and poaching meteorite fragments. So the University of Alberta in Edmonton, Dr. Chris Hurd, who's an eminent meteorite scientist and friend and colleague of ours, asked Steve and myself if we would please come up and search their restricted area and recover as many fragments as we could before they were poached, stolen by poachers. And it was a fascinating experience for us because, well, first of all, there are certain areas where you couldn't walk 2 feet without finding a target. And as a meteorite hunter, you sometimes go days or weeks, or in tragic cases, even months without getting a good target. And we could hardly walk for 30 seconds without finding another one. So we mapped the location of every piece that we found. The depth at which from which we excavated it, the average was less than a foot. The maximum depth was 14 inches. The orientation of the piece, how it was lying in the ground, and what type of soil it was in. And then all the pieces that we found, hundreds and hundreds of pieces, we donated to the university collection, where Chris is probably still working with them. And he produced an extraordinary three-dimensional map showing not just the dispersal of the pieces, but their depth and orientation. And it was a unique study in meteorite science because it was the first time a crater had been located that was relatively undisturbed, and hardly any pieces had been removed at that time. So we helped to paint a very comprehensive picture of what happens, how a meteorite explodes, how it excavates a crater, and how those pieces are dispersed. It was definitely a thrilling time. Here's an even larger crater. This is in Murasko in Poland. This is several thousand years old. I should have mentioned that the Whitecourt crater there in Canada, that impact occurred only 1,100 years ago, so very recent in geologic terms. The Murasko crater field in Poland is thousands of years old, and as you can see from this, some of them are filled with water. And for you James Bond fans, this always really reminded me of the You Only Live Twice scene where he takes the autogyro into the volcanic crater with the green water, and that's where the secret evil base is. And so I always called this the James Bond crater when we were out there. So you've probably noticed the craters are getting larger and larger. This is the Monterrey crater in the Atacama Desert in northern Chile. This crater is 1 million years old, and this was one of the most fantastic experiences for me because it is way the heck out there. It's extremely difficult to find. We needed a convoy of 4-wheel drive vehicles to get up there, and there's no restrictions here. There's no guide, there's no barricade, there's no ticket booth. And so we carefully drove our trucks down onto the floor of the crater and we camped there overnight, which was a thrilling experience for a meteorite and space nut like me. And there are still tiny weathered fragments to be found at Monterrey. So that tells us that under ideal conditions, because the Atacama is extremely dry, an iron meteorite will last about 1 million years on Earth. This is an aerial view of Meteor Crater in Arizona that I mentioned earlier. This is a protected site. It's prohibited to collect meteorite fragments there, but thousands of pieces have been found over the years, and you still can sometimes find them for sale from old collections when collecting was legal there. But because it's such a unique site, it's the largest extremely well preserved crater on Earth. And so rightly, the owners and curators seek to keep it that way. And it's still an important site for scientific research. Not so much meteorite science, but there's some work still being done, but loads of work's been already being carried out at the crater. But it's also has a unique situation in the atmospheric sciences world. There are very unusual weather patterns that occur in and around the crater, and that's still widely studied. And we actually did a couple of episodes of my STEM journals show there. So when I finally got down onto the floor of the crater, it wasn't to do with meteorites, it was to do with atmospheric sciences, but I gladly took any reason. It's a fantastic experience to hike down onto the floor of that. That was definitely a once in a lifetime thing. And this is perhaps the largest inhabited crater in the world. This is the German town of Nördlingen, which is fairly close to Munich in central Germany. And if you look carefully at towards the top of the photograph, you'll see a line of blue hills that looks a bit like the Blue Ridge Mountains. That's actually the rim of a gigantic multi-million-year-old meteorite crater. And the town of Nördlingen sits just about in the middle of that crater. So that gives you an idea of what a really large asteroid fragment does to Earth. Fortunately, they built the town after the impact, or it wouldn't look quite like that. Well, so how do we find meteorites? How do we get out and find them? Well, compasses are all very useful. Also, typically driving like a maniac in very strange off-road environments. I'm a bit embarrassed to say that was actually me driving this vehicle. This was in the Australian outback. Steve and I were absolutely determined to get to the Henbury craters in the Northern Territories, even though they were experiencing the worst flooding in 35 years. So if you want to hunt for meteorites, you really need to be determined and sometimes take absurd risks in order to get out there. So I mentioned at the beginning of the talk that the vast majority of meteorites are very rich in iron. So we often use metal detectors to search for buried targets in the desert, in the winter. Just like a good postal worker, no type of weather is going to stop us from our destination. Here is a very happy find. This is the site that we were trying to get to in the previous photograph, that driving through the flood. We were trying to get to this site, to Henbury Craters, and as you can see, it was very well worth it. I should mention again, this is also a protected site. This is a national monument curated by the Australian Park Service. We had a very special and explicit permission to hunt there for a few days, and that was a dream come true for me to find pieces at this site. It's one of the most interesting crater sites in the world. There are about 17 meteorite craters right on top of each other that all formed at the same time. This impact about 4,500 years ago. And if you want to find the really big meteorites, unfortunately, they're usually very deeply buried. And so the larger a detector you have, the deeper its signal is going to go. And when you do get a target, there's usually a mixture of elation and fear, especially at this site in Poland, which had been a battlefield during the Napoleonic War, World War I. There's an elaborate World War I trench system that's still visible, and artillery positions, and World War II. So there was loads of shrapnel and military debris lying around. When we got this big target, I was a bit concerned that it might be an unexploded bomb. And Steve was wailing away with his pickaxe, trying to get down there as quickly as possible. And I did have this horrific vision in my head of his pickaxe hitting the tip of an unexploded bomb and us being blown to bits. But fortunately, that didn't happen. And we ended up recovering the second largest meteorite ever found in Poland at that time, and also the deepest, at over 2 meters. It took us several days of excavating to get it out. And that's what a deeply buried meteorite looks like when you first encounter it. I cannot begin to tell you how many times we've gotten down there and it's been an engine block or an old trap or a pipe or some unidentifiable bit of metal. And there have really been some fallen faces many times. It's not always good news when you get to the bottom. One time it was an uncapped oil well, and we were just really fortunate not to have fallen in. This was one of the largest finds we made. This is what the detector saw from 5 or 6 feet underground. It was in such a viscous clay that we had to bring in a tractor to excavate it. And when it came out, it looked like that. So that is that's a really good day meteorite hunting. After about 30 years of doing this, I've only had a handful of days like that where a space rock weighing hundreds of pounds comes out of the ground. You don't forget that in a hurry. I'm often asked what's the strangest thing I've ever found in my travels, and it would definitely be this. This was an unexploded 2,000 pound Vietnam era warhead that sadly landed outside the military testing range at Dagway, not inside where it was supposed to be. We were evidently the first people to ever stumble across it, and we reported it to the Air Force, and they sent in some unexploded ordnance guys who determined it too dangerous to move, so they blew it up on the spot, and they congratulated us for not going anywhere near it because it was extremely dangerous. So as you can see, I did not go anywhere near that, and was complimented by an Air Force colonel on that. He goes, yes, yes, well, those things are very sensitive. And if you get a couple of guys traipsing up in boots, pickaxes, they can just go off. So it's lucky you didn't stop and take any photos or anything. And I was going to say, for you spaceflight enthusiasts, you're all spaceflight enthusiasts. One of my most beloved projects was the opportunity to serve as executive producer of the documentary film First to the Moon, the story of Apollo 8. And this featured all new interviews with the Apollo 8 crew. It's a really wonderful feature film that was released a few years ago. And some of you will remember that we screened this at a couple of NSS events over the years. It's on Canopy and I believe Prime. It's quite widely distributed. So a beautiful film. Our director did an absolutely wonderful job, and with an original soundtrack. So I'm a great fan of the Apollo 8 mission, and as are probably many of you. So I just wanted to share that with you for those who are interested. It's quite easy to find. And as Tony kindly mentioned, I'm an author, written several books. This was my first memoir. This was in large part about the adventures traveling around the world, making Meteorite Men, and how I learned to meteorite hunt. When I first met Steve Arnold, my co-host, many years before Meteorite Men back in the 90s, pre-internet or very early days of the internet, there's no meteorite hunting book like there is now, or television shows or YouTube videos or anything. We had to figure it out ourselves, and there were a lot of mishaps on the way. So that book is in print and easily available, as is this, my most recent book. The most frequently asked questions I get in my work are, how do you find meteorites, and can we go meteorite hunting with you? So I shared all the information that I have in this book. It's widely available online, easy to find. So my my decades of arcane knowledge are shared in that book with loads of illustrations. And I will mention that I am the founder and chief executive officer of Aerolite Meteorites. We're a world leader in meteorite recovery and sales and identification, education. Excuse me. If you would like to learn more about meteorites, or if you would like to have one, please visit us at aerolite.org. We have a modern and exciting website. And if any of you happen to be in the Southwest over the coming weeks, the Tucson Gem Show, the International Gem Show, opens this coming weekend, and we are exhibiting as always. In fact, I was there yesterday having a look at all the new goodies and finds. And I do my own social media. I'm friendly and accessible. So if any of you would like to chit chat or ask questions, please reach out to me. I'm easy to find. I'm Geoff Notkin on those platforms. And that concludes the slideshow. So